Hello there, I am Dr. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Thank you very much for joining me once again on this channel. You've been quite wonderful in following me in this series that we've been going through. Today we're going to look at one more example of dealing with dependent variables. Dependent events in probability, and in this case we're looking at multiplication of probability. Now, I had said in an earlier video that when you're looking at dependent event, it means that the outcome of the second one is dependent on the outcome of the first one. The outcome of the second event or the third event is dependent on the outcome of an earlier event, so that the ratio and the denominator or even the numerator of your probability will be affected. Let's look at this classical example on the board. Here we are looking at a question that says that a cup contains 4 blue, 2 red, and 3 black buttons. If 3 buttons are drawn from the cup one after the other without replacement. Remember, this is the key word, without replacement. What is the probability of drawing 2 blue and 1 black, 1 red and 2 black, 2 blue buttons, 2 red and 1 black button, then 3 black buttons? Let's look at the solution to this. Now, the solution, as we usually start, is to look at what is our sample space. So our sample space in this is 4 plus 2 plus 3. So that 4 plus 2 is 6, 6 plus 3 is 9. So our sample space is 9. Now 3 buttons are chosen at random. What is the probability that we have 2 blue and 1 black, one after the other without replacement? So we'll start with a probability of 2 blue and 1 black button. So that's how do we solve this? It's going to be probability of first blue times probability of second blue times probability of black, of taking black. So now probability of first blue is going to be, we have four blue buttons, so that will be 4 all over the total number, which is 9, times the second blue. Remember, we're taking without replacement, so that means there will be 3 blue buttons left, and then there will be a total of 8 buttons left in the cup. So this becomes 3 all over 8 times, what do we have in the next case? We have 1 probability of the black button. So now, how many black buttons we have? We have 3 black buttons, but the number of buttons we have left in the cup will now be 7. 2 buttons have been taken earlier, so we're left with 7 buttons. So the task now is to find the solution to this problem right now. Now, what do we do in order to solve this? Quickly, don't be scared by looking at this scenario that you have to multiply, what you do quickly is to break your fractions down. So let's break this down. Let's have 4 can go here 1 and 4 will go here 2. Are you seeing it? 3 can go here 1 and 3 can go here 3. We still can divide this. 3 can go here 1 and 3 can go here 1. So that in the end, what do you have? 1 all over 2 times 7 is 14. So this is the answer to the question. 2 times 7 is 14. So the answer is 1 all over 14. So that's the probability of picking 2 blue and 1 black. So the probability of selecting 1 red and 2 black buttons, 1 red and 2 black buttons, that will be probability of red times probability of first black times probability of second black. Okay, so that will give us probability of red. How many reds we have? We have 2 reds all over the total number of buttons we have. So that will be 2 all over 9 times probability of first black. We have how many blacks? 3 blacks. We have 3 blacks. We have 3 blacks divided by the total number of buttons left. Number of buttons left will be 8. Remember, we're talking about without replacement. So the total number of buttons left are 8. Now times the second black, we now have how many blacks left? 2 blacks. And the total number of buttons that will be left will be 7. So this becomes 2 all over 7. Are you following? Okay, good. So what we'll now do, break this down so that it not be difficult for us to deal with. So 2 can go here 1, 2 will go here 4, 2 will go here 1, 2 will go here 2, 3 will go here 1, 3 will go here 3. So it becomes easier. So we now have 1 times 1 times 1 is 1 all over 3 times 2 is 5. 5 times 7 is 35. So we have 35. So the answer to number 2 is 35. All right, let's move on to number 3 quickly. All right, number 3 is to find the probability of 3 blue buttons. 3 blue buttons. And to get that, it's going to be probability of first blue times probability of second blue times probability of third blue. Okay, probability of first, second, and third blue. So probability of first blue is what? How many blue buttons? We have 4. 4 all over 9 times the number of buttons, the number of blue has reduced, and the total number that is still there now has also reduced. So that will be 3 all over 8 times the third blue. Third blue, we're left with 2 buttons left out to pick out, and the total number has also reduced. So we have 2 all over 7. This is without replacement. So let's do our let's break this down. So 2 will go here 1, 2 will go here 4, 4 will go here 1, 4 will go here 1, 3 will go here 1, 3 will go here 3. So that our answer is 1 times 1 times 1 is equal to 1 divided by 3 times 7. That gives us 21. So our answer here will be 1 over 21. I trust you are following. Thank you. So let's look at number 4. Number 4 says, what is the probability of 2 red and 1 black? What's the probability of that? That will be probability of first red first red times probability of second red times probability of black, as the case may be. That's left. So probability of first red, how many reds do we have? We have 2. So this will be 2 all over 9 times second red. We're just left with 1 red. So 1 all over 8, because the number of total number of buttons are produced by 1. So times, how many blacks do we have? We have 3 blacks. We have 3 blacks divided by the total number of buttons we have now has become what? Has become 7. So let's multiply as usual. 3 will go here 1. 2 will go here 1. 2 will go here 4. 3 will go here 1. 3 will go here 3. So what's the answer? Our answer will now be 1 divided by 3 times 4 is 12. And 12 times 7 is 84. So you have 1 over 84. Last but not the least answer will be our 3. What's the probability of 3 black buttons? So to find this, it will be probability of first black times probability of second black times probability of third black. Okay, now the first black, as we know, we have 3 blacks at first, so that will be 3 all over 9 times the second black will be 2 all over 8 times the third black, you already have 1 times 1 all over 7. So let's multiply through. Let's break it down. 2 will go here 1, 2 will go here 4, 3 will go here 1, 3 will go here 3. So our answer will be 1 times 1 times 1, that's 1, divided by 3 times 4, that gives us 12. 12 times 7, it's going to give us 84. So 84 on this side. So this is the answer to the question on dependent events. See you next time as we look at more examples ahead. God bless you.